All right, so back to the homework packet. 28, model rocket problem. Another one of these gravity problems. This is actually the same as, more or less, what we did in class yesterday. The height h in feet of a model rocket t seconds after launch is given by height is 256t minus 16t squared. As the rocket descends, it deploys a recovery parachute when it reaches 200 foot above the ground. At what time does the parachute deploy? So the height that this is going to happen is at 200. If you need more of a better explanation than that, well, the rocket goes up and then the rocket comes down. And we're interested in where the height is 200. Right there. So that's why we're replacing the height with 200. I'll shift everything left on this one. I don't think you can pull a 16 from 200, but I'm pretty sure you can pull an 8. What is it, 8 times 25? So yeah, I'm going to make the numbers smaller. Pull 8 from 256, I think you get 32. And then 25. And I forgot a 2 there. Looking at that, I don't see how I can get to a 32 using a 2t, a t, and a 5 and a 5. So it's probably not going to factor. So I'll just use the quadratic formula. The last one I did with y'all, I did to complete the square. But anyways, I'll go ahead and do the quadratic formula here. So x is going to be opposite b, which would be 32, plus or minus the square root of a 32 squared, minus 4 times a, which is 2, times c, which is 25, all sitting over twice a 2. That's the advantage of pulling a number. It makes these numbers smaller. That's why you do it. Which is nice if you want to do it by hand. I don't. But it's still smaller numbers. So there's an 824 stuck in the radical. So x is 32 plus or minus the root of 824 over 4, both pieces over 4. That'd be 8 plus or minus something. Just because you guys are honors kids, try and simplify your radical. It's not divisible by 16. It should be divisible by 4. It is. And then 206. 206 is divisible by 2. Then you get 103, which is not really divisible by anything, is it? Not that I can think of. So it reduces down to 2 root 206. Which isn't going to be doing you a whole lot of good. You'd have 8 plus or minus root 206 over 2. Now the reality is this is kind of a real world situation here. That's really hard to read, isn't it? 8 plus or minus root 206 over 2. Right here is probably where you should have just played with the number. Root 824 divided by 4. So we're 8 plus or minus 7 1/18 of a second. Which one matters? Well, if you did the subtraction, you get that your time is roughly 82 hundredths of a second. And if you did your addition, you get that your time is about 15 1/18 hundredths of a second. Those are the 2 times that the parachute hits that 200 foot mark. The first time would be over here on the way up. The second time would be on the way down. So it's 15 1/18 hundredths of a second. Then you got some more completing the square problems, because they are important. 9 is going to move over. We're going to take half of b. B is a negative 5. We're going to square it. We're going to get 25 quarters that we add to both sides. This is going to factor perfectly as x minus 5 halves squared. 9 and 25 quarters. If you think of 9 as 36 over 4, you got to do 36 plus 25, which is 61 quarters. Counteract squaring by square rooting. We love pandas. Don't forget the plus or minus symbol. 61 is not going to simplify, or is it? No, shouldn't. And then we counteract the subtraction with an addition step. So 5 halves plus or minus root 61 halves. Now what's up with 30? 30's got a whole number in it. 5's already where I want it. That's kind of nice. So 30 is just ugly because it's got lots of fractions. We'll have x squared plus 3 quarters of x is equal to 5 quarters. If I take half of 3 quarters, I would get 3/8 because I shift the 2 up. So I take my 3/8 and I square it, and I get 9/64, which is what I add to both sides. All right. Right-hand side sums to be, why did I do that too? Oh yeah, got ahead of myself here. To turn a 4 into a 64, what would you multiply by? 16? So this becomes 80, because 5 times 16 is 80. Add 9, this is 89/64. The left-hand side is going to factor as x plus 3/8 all squared. We're going to counteract the squaring by the square rooting. We're going to have root 89 over 8 plus or minus. And then we're just going to subtract 3/8 and be done with it. So x is a negative 3/8 plus or minus the root of 89/8. See that bleed going through there, can't you? Let's see, make a table containing the vertex, then sketch the quadratic inequality. It says, P.S. I want to see your table. I do want to see your table. I really do. If you were to try to do the vertex formula here, the x-coordinate of the vertex is opposite b over 2a. This is like plus 0x plus 0, right? Opposite b would be a 0. The vertex is at 0. The y-intercept is at 0. It's right here. So one thing I know is I have the point 0, 0. I'm actually going to put it in the middle because this is my a value, my initial slope, fall 3, run 1, fall 3, run 1. So I'd be -1, -3, +1, +3. There is my little bitty quadratic. It's actually not that hard. Over on 32, oh, there's shading. I forgot these are inequalities greater than. I need to be shading above or around this thing. Okay, what's up with this one? Also in standard form. I'm going to go after the vertex first. The vertex again, the x-coordinate of the vertex is at opposite b over 2a. So that'd be -8 over twice a -2, which is going to be what, 2? And to get y, I plug it back in. So if I plug in a 2 here, I'd have 4 times a -2 is -8. I'm just keeping that in my head. 2 times 8 is 16. 16 minus 8 is 8. Take away 5. It's -3. I'm going to go ahead and plot that one. Right 2, fall 3, closed hole. I'll go ahead and draw my line of symmetry because I'm going to do this one next. I'm not going to do this one using initial slope. I'm going to go after the y-intercept. The y-intercept happens when x is 0. And if I plug a 0 into here, that piece is gone, that piece is gone, and I'm left with -5. Hmm. Sorry, something just seemed wrong. It's bugging me actually a little bit. Making sure I got everything else right. If I plug in a 2, that'd be 4, negative 8. That would become 16, which is 8 minus 5. This is supposed to be positive 3, isn't it? That's why things seem so wrong. I knew something was wrong about this. The reason I was sitting here staring at this thing is because the initial slope is supposed to be fall 2, run 1. It didn't make sense. So that's what was throwing me off. Anyways, back to this thing. If this is my y-intercept and it's 2 units left, there must be another point 2 units right. And it's going to be at 4, negative 5. Remember those two match when you use symmetry? There's your parabola. Shading matters. It says less than. Below, we'd have to be on the interior. Two more quadratics here. This one is in vertex form. This is in the form a times x minus p times x minus q, where p and q are your x-intercepts, or your roots, which is another word you'll hear. They're your roots. So my x-intercepts happen at 2 and negative 4. All right? The y values would be 0 because they are x-intercepts. They are on the x-axis. You may not realize that until you actually plot the point. Some of y'all are a little slow. No offense. Heck, you just saw me make a mistake. And right smack dab in the middle of this would be my line of symmetry. You can use the formula p plus q over 2 if you want, but when the numbers are nice, just draw it. That happens when x is 1. So now you plug a 1 into it, figure out what the other point is. By the way, these should actually be open hole. Should be open. If you look at your symbolism, it's a less than symbol. So I plug a 1 into this thing, and I am actually too tired to do this in my head right now. So I need to see it. This is a negative 1, that's 5, that's negative 5 when you multiply them together. Times 2 is negative 10. Which is going to be all the way to the bottom. Dashed lines. We have the less than symbol, which means below. And once you realize where something's below, you realize that you're actually just shading all the way around this thing. And there's 33. On to 34. 34 is in vertex form, which is nice. A times x minus h squared plus k. So I think about my vertex. My vertex is going to be at 4, negative 3. So to the right 4, fall 3. It needs to be open hold. You could use initial slope here if you wanted to. I don't know that you want to go after the y-intercept, but you might. If you go after the y-intercept, this becomes 16, doesn't it? Because the x value is 0. So plug that in. This becomes 16. Half of that's 8. Take away 3 is 5. That wasn't so bad. 0, 5. I'm going to draw my line of symmetry because it makes it easier on me visually. 4 left means I go 4 right. And looking at my inequality symbolism, that's a greater than symbol. It doesn't have equality. I need to be dashing. And if I'm going to be bigger than this, I'm going to be shading the interior of this one. So there's that dude. Oh, I forgot to plot that point, didn't I? This would be at 8, 5. So there is 28 through 34. Is there any more of them than I did? I'll probably pause this video or stop it. And I don't know if I'll do any more of it today or not. We're almost at the end of it. So that's kind of cool. This is a good stopping point because I got stuff to do.